Hello, ham radio friends. It's been a long road getting the AAZ2 circuit board working here. So as you know, my friend Bob and I have been working on the circuit board, software, and we're taking the Rig Expert AA02, and for the price of less than an AA35, you can have an AA1000. So for under $200, probably around $150-ish, $160. Haven't priced it out yet. So we've been fighting with EZEDA, the circuit board layout software that's just quirky, weird, buggy in some circumstances. But we finally got to a really good place that we can see the light at the end of the tunnel, and it's not a fast-moving train. It is actually daylight. So this is what the circuit board looks like, a two-dimensional view. It's based on the ESP32, which is about $7. It uses the Rig Expert 02, and that's $100. And then your three-dimensional view, it has parts on both sides, made it a little more trickier. So the Rig Expert plugs in here, just like that. And the laser, which is about $6-7, plugs into there. We're going to have 3D printed little bracket mounting holes, and we're working on a 3D printed case. Everything's going to be open source, MIT license, free towards the community. And all the resistors are 10K unless otherwise marked, 2.4K on the I2C pull-ups, 0.1 bypass caps except for the 1 microfarad cap. And then we come in with a booster battery charger, which is about $2-3. We got ground, their battery sense, and our 5 volts. And we got test points, 3.3 volts, 5 volts. And we do have I2C future expansion in case we want to add something else to this. So the back of it is the actual top side, which is the LCD display, plugs into there. All the data lines are clearly marked. Control signals are marked. Display connectors. And the laser shoots out the side over there. And we got a battery level sense. There's only like 2 things you got to calibrate, and that's you'll measure your battery voltage, and based on these 10K resistance tolerances, you'll set, when you got about 3.7 volts or more, you'll set your display to 100%. So there's a config parameter that you just got to type in on the serial port. And the other thing you have to calibrate is the distance from the laser to the plastic box. Right now we set it at 1 inch, but it'll probably be less than that. However, the box, comes into play. So when you're measuring your antennas, we'll pick a value, a distance value that's 0. And it won't, and of course the laser will be recessed, so we'll be subtracting off 1/4 inch, 1/2 inch, whatever it happens to be. And the encoder could mount on the board. If you use a different encoder, we can just use wires to the encoder. And that is about it. This is untested. We did not make boards yet, but we're still going over all the pinouts, and we don't want to be making a bunch of boards that oh, we forgot this or this didn't line up right. Physical dimensions are always such an issue. The Rig Expert board goes with the logo on top, just like you see the board. You should see Rig Expert about in the same area, and the pins will go facing down. The USB connector on the Rig Expert board will be below the board. So make sure you solder your pins correctly and not get it upside down. This is a ESP Varoom. It is this is the ESP32, this actual chip, but this daughter board or breakout board, there's a bunch of different pins. So we labeled all the pins and make sure the one you buy matches exactly all these pins, because people will have less pins. I think this is the most pins you can have, but there might be some that with less pins, they're smaller, different footprint, and some have the same exact footprint, and they have the pins and the signals in different places. So you want to make sure that that fits. There's about 112 solder points, I believe, according to the software. And that's the front side and the two-dimensional, and then the bottom side, which is your LCD, looks like that. So my friend is out of town. When he comes back, we're going to go over this, and hopefully we'll have some boards and get our first alpha boards in, and if they become production, because we don't really want to do this twice, you know. It takes a long time to get them from China, 8-10 days, and shipping's expensive and stuff like that. So that's kind of like what we're looking at. So that is the AAZ2 version 1.0, 100 kilohertz to 1 gigahertz antenna analyzer designed by Bob and I. And you'll see more things posted on the website and at YouTube. So 85% of you guys are returning and watching these videos on YouTube, but you're not subscribed. So I'd appreciate you. Ring the bell, give me a like, a thumbs up, and a subscribe, and tell me what other things that you would like to see. I'm working on CNC bed leveling. That'll be a YouTube video next too, with some free software applications. All right, hang tight, hang in there. It's coming. You're going to get a great analyzer because, you know, you got time to market, a quality product, and cost. We're keeping the cost really low, and we're trying to give you a high quality product, really good. So our time to market is taking long because we started this at the around the end of May, June, and we had a lot of issues with rig experts. They're not answering emails and stuff like that. Maybe someone will take this whole thing and sell it as a kit or write a magazine article or whatever. I don't want to deal with circuit boards and stuff like that. I want to just do a kind of a one-time shot, maintain the software here and there. I'm a software person. I'm not a mechanical engineer. I'm not a circuit board layout person. So we struggled in a lot of areas here, but I'm very, very, very happy with the results, breakthroughs in the last few days. Really, really, it's making it all worthwhile now. So thanks a lot. Don't forget to subscribe and like the channel. Thank you.